Hello friends, this is Durga again from IT University. As part of this video in CCA Spark and Hadoop Developer, I'll be talking about filtering data into a smaller data set using Spark, using Scala as the programming language. So let me review the code. So filter is a transformation. So you can apply filter transformation to filter out the data that is not required and only process the data that is required. So if you want to apply any filtering, filter is the transformation you need to use. So you can go to the Spark documentation in this link and go to, so this documentation will be available as part of at the time of certification exam also. You can click on this Spark programming guide, and then if you go to the transformations, so these are the transformations, and you can see filter as one of the transformations. If you look at the meaning, it returns a new dataset formed by selecting those elements of the source on which function returns true. So it returns Boolean variable, and wherever it returns true, that records will be put to the next step in the code. So let's start. In this case, I will be reading data from orders. So I'm actually using sc.textfile command to read the data. So I need to start Spark here. And as part of the certification curriculum, they have specified that they will be providing Cloudera cluster with I think 5.3. Where is that? 5.3.2, which will have Spark 1.2.1 or 1.2.0, and hence we have to use 1.2.1 to practice in the similar environment. So this is how you can launch the Spark shell command line interface. Once it is started, you can okay, this is actually Python. To launch the Scala based Spark command line interface, I have to use Spark shell, not PySpark. And hit enter. So for this, you need to be aware of the transformation called filter, and also you need to be aware of how you can actually compare values in Scala. So this is Scala code which is embedded as part of that filter function, which is provided by Spark APIs for Scala. So let's see. First, let us read the data. I have already covered this. Paste. Now orders RDD will have will be pointing to the files under this directory, and then if you look at the data, let me open another window here. MySQL -u retail underscore DBA -p Cloudera is the password. And here, if you look at, I have to use retail DB, that is the database name, and then describe orders. So orders have 4 columns: order ID, order date, order customer ID, and order status. I just want to see what are all completed order statuses. In SQL world, you can just say select star from orders, where order status equal to whatever status it is. Let's get all the distinct order statuses. Distinct order status from orders, and hit enter. So these are all these things, and if you want to get all the orders that are completed, you just have to pass it as part of the function in filter. So okay, so orders RDD dot filter is the transformation you need to use. You can say underscore as well, dot split comma contains or equal equal is to compare the exact string, equal complete. Okay, and then you can actually collect for each println and hit enter. I have to close one more bracket here. I think it's not complete. It's complete only. Okay, I know where the problem is. So in this, I have to get the last field, which is order status. So after split, it actually returns an array, and we have to get the last field which contains order state. So here I have to use subscript 3 because after splitting by comma, the subscript 0 will have order ID, 1 will have order date, 2 will have order customer ID, and 3 will have order status, and hence I am using 3 here and then comparing with complete and hit enter. Now you can see that it is returning all completed records. That's how you can use filtering. You just need to be familiar with the functions like equals, contains, and also the operators such as AND and OR to actually apply advanced filters, and all of them are provided as part of my GitHub account. And this one actually get all the completed records. This one will get all the records which are in pending state. If you look at the data here in MySQL, for pending, there is a pending and pending payment. So there are two types of statuses which have pending, and hence we have to use contains rather than equals here. It will get all records which have pending in the string pending as part of the status, and hit enter. Now you can see that it is getting records for both pending and pending payments. Similarly, if you want to compare, you can use standard comparison operators. In this case, it will fetch all the order IDs which are greater than 100. There is no proper business logic here. Just I'm trying to show you how you can actually use greater than, less than symbols on the values. You can use all standard comparison operators, greater than, less than, greater than or equal to, less than or equal to, etc. And this shows how you can actually use AND and OR operators. This is OR operator. For AND, it will be double ampersand. Here it will get all the order IDs which are greater than 100 and all the statuses which have contains in them. So I can actually copy paste this one. And also here I am using line implies line dot split. You can either use you can create a name for the parameter and then use that name as part of implementing the functionality on that, or you can just use ampersand as I have shown earlier. So let me paste it as is and then collect for each println and hit enter. Now it get all the statuses or all the orders which have order ID greater than 100, and or if it contains pending, it's OR condition, so you will get all kinds of stuff. Rather than greater than, let me use less than here. It will return only 100 records. Or it will return all the pending. Here I will just use take 1000 and hit enter, and now you can see that it returns it returns all the orders that are below 100 and also all the orders that are greater than 100, and irrespective of the status it returns. So it's an OR symbol. So either we are getting all the pending orders or all the orders that are less than or equal to 100. Let me do this. let me use 150 and hit enter. Now you can see you got all the orders which are less than 100. Because it's an OR operator, above 100 it is only returning pending payment and pending orders. So that's how you can apply operators such as OR and AND, which are Boolean operators. And this is more complex operation. Here we are trying to get all the orders that are greater than 1000, order ID that are greater than 1000, and then all the orders if they are pending or in cancelled state. So that one also can be applied. So in this case, you have to be careful where how you are managing your brackets. So OR has to be applied between the two. So it has to be in one bracket, and then another condition is this one. If you want to implement OR on this, then you have to enclose it in bracket. So if you are familiar with how you can use OR and AND operators in standard programming language, the same principles apply here also. And if you want to say not equal, you can use this one, or not contains, you just prefix with exclamation mark, which will be negation of the filter you are applying, and only those does not satisfy this one will actually return. Okay, and now we will see a little bit more complicated use case. In this case, I want to get all the orders that are cancelled and the amount is greater than $1000. In this case, we have to get only cancelled orders. So for this, you have the order amount in order items table, and that too each order have multiple items. So for example, here we have 68,883 orders, and we have 172,198 order items. The reason is order items is a child table, and each order can have multiple order items in it. So as we have already described orders, it does not have revenue column in this. The revenue column is in order items. So if I describe order items, you can see that there is a column called order item subtotal, which can be used to get the revenue per order. So as we will have multiple entries in order items, we have to add all those entries for a given order to get the revenue for that order. So for example, select star from order items, order by order ID, limit 100, and it is order item order ID. So this is the column name which actually refers orders table order ID, and hit enter. Now you can see that this is the order ID. For order ID 37, there are two order items, 99 and 100, and the revenue is 59 and 99. So it's approximately $160. So select sum of order item subtotal from order items, where order item order ID equal to 37, and hit enter. You can see that it's $160. So we have to add order item subtotal for all the order items for a given order, and then we have to compare with 1000. So this requires aggregation of the data at the order level, and then we have to run the comparison. Okay, and once you have the subtotal aggregated per order, you have to filter out if it is greater than 1000 or not. So the most efficient way, a lot of people tend to join order and order items first, and then compute the revenue, and then compare if the revenue is greater than 1000 and if the order is cancelled. People can implement that way, but that is not efficient way, because if you look at the table, select order status, count of 1 from orders, group by order status, and I want only cancelled. So even though we have 68,883 records, only 1428 are cancelled, and of these 1428 orders only, I want to check whether order revenue is greater than 1000. So if you filter as early as possible, discarding all the unnecessary records, that solution is much better than pre-joining all the tables and then applying filters at the end. So not only you should understand how to filter the data, you should also be capable of designing your applications in such a way that data is filtered as much as possible, as early as possible in the processing flow. So the way we will be implementing the requirement of all the cancelled orders with amount greater than $1000 is that we will get all the cancelled orders first, then we will join orders and order items. So we will be getting only order items for those 1428 orders, and then we will compute the revenue, and then we will filter the data which amount to greater than 1000. Okay, so for that I am starting to develop the code. Orders RDD already have what we are looking for, so I use the same thing, and then I want to filter out all the non-cancelled orders. So let me create orders cancelled equal to orders RDD dot filter, and I can use underscore without using the name to the parameter. I have to split by comma, and the fourth element is the one which have the cancelled in it, so I can use equals cancelled. Okay, now it will give all the cancelled orders. I can validate by saying orders cancelled dot for each println. I think I have to use collect. Okay, no need to use collect. So I get all the cancelled orders here, which are approximately 1428. I can also do the count. You can see that I got 1428 records. Now I want to get order items, so I am creating order items RDD. Here you can either pre-aggregate and then join, or first join and pre-aggregate. The better way will be to first join and then pre-aggregate, because there are only 1428 orders which for which we need to fetch the order items. Hence the number of order items that needs to be aggregated will go down considerably. Instead of running aggregation on 172,198 records, you will be doing aggregation on much fewer records. But in a truly larger set, you have to try both and then determine whether to aggregate first and then join, or first join and then aggregate, because join is expensive, and aggregation can actually be done using combiner by using reduce by key and aggregate by key, and it could be faster on very larger data set. So you have to try both, and then you have to determine the final solution, whether to use join first and then aggregate, or aggregate first and then join. In this case I will first join and then aggregate. Now we have order items and order items RDD, and now I have to map these two things so that I apply the transformation to get the order ID from these two data sets, so that the data can be joined. So val orders cancelled map equal to orders cancelled dot map, and rec equal to, here I want to get rec dot split comma, the first element is the order ID and the value for the tuple is the rec itself. I want to get all the details about the orders table, and then I can close the bracket. So this will emit the order ID as key and the record as value, and you can actually validate by saying orders cancelled map dot take 5 for each println and hit enter. You can see this is order ID, and this is the record itself. Similarly, we have to apply on top of order items data also. So order items map, in this case order items RDD dot map, and in order items the second column is the order ID, so I have to use 1 here, and hit enter. Now you got orders with orders map with order ID as key and orders data as value, and you got order items map with order ID as key and order items record as value. Okay, you can also say order items map take 5 for each println and hit enter. So this one is the order ID. You can see that all these three have the same key, and these are the order items records. And then we can run orders join RDD equal to order items map dot join orders what is the RDD name? I think order cancelled map, orders cancelled map. Okay, orders, I think it's single L. Yeah, now you can say orders join RDD dot take of 5 for each println, and you can see that it created a tuple with order ID as key because that is the join field, and then it has a nested tuple which have both order items data and orders data. So from here to here it is order items data, and from here to here it is orders data. It is again a tuple, so it has two values in the tuple, two elements in the tuple. The first one is order items record, and the second one is orders record. Okay, now we have to use this data, and then we have to aggregate based on the revenue, which is this field order item subtotal, and then we have to compare with 1000 and get only the cancelled orders which are greater than 1000. You can also say orders join RDD dot count to see how many records are we are trying to process. We are trying to process 3519, which are related to approximately 1400 cancelled orders. Okay, now we have orders join RDD, and let me say orders val orders ag RDD equal to orders join RDD dot, you have to map and get the order ID, which is the first element in the tuple, and in the tuple the way you can fetch the record is by using the underscore notation, not the circular brackets notation. Circular brackets is to read the elements from the list. To read the elements from the tuple, you have to use underscore notation, and in this case the first element in the tuple is represented by rec dot underscore 1, so which will give me the order ID, and then rec dot and then I want to get the order item subtotal, which is rec dot underscore 2 dot underscore 1, because if you look at the data, this is rec dot underscore 1, and the order items record will be rec dot underscore 2, which is of type string, and I have to use apply split operation and fetch the fifth element of the first attribute in the tuple, which is represented by rec dot underscore 2 dot underscore 1, and I have to apply split on rec dot underscore 2 dot underscore 1, split by comma, and then get the fifth element from the from order items record. So rec dot underscore dot 2 dot underscore 1 dot split by comma, and which element we want to get? We want to get the fifth element, which is represented by 4, and then hit enter. Okay, now you can see orders. Actually, let me rename it orders ag map RDD. Okay, now I can say orders ag map RDD dot take of 5 for each println and hit enter. You can see it is getting the order ID 59,507 or 10,065, and then revenue from order items table. Now, actually, to add it without any issues, I have to convert this to float, otherwise you can run into type mismatch issues. So now it will be float. We can see the result, and then we will create orders ag RDD, in which we want to get orders ag map RDD dot. You can apply reduce by key here, because we are trying to aggregate the results. Hence, you can either use reduce by key or aggregate by key or combine by key. But aggregate by key and combine by key should be used only when your input type to reduce by to the aggregate function is different from the output type, or the combine logic and the reduce logic is different. Then only you should use the aggregate by key or combine by key. Both are not cases here, hence we can directly use reduce by key, and in this case I just have to say accumulator comma value implies ACC plus value. So I have covered all the reduce by key, aggregate by key, and all those things at the time of aggregations. I'm just revisiting why I'm using reduce by key here. Aggregate by key or composite by key also can, combine by key can also be used, but they're more complicated in this case and they're not necessary. You can safely use reduce by key. Aggregate by key or combine by key you should only use if the input type to the aggregate function is different from the output type, or the combine logic has to be different. Only in those two cases you can you should consider using aggregate by key or combine by key. If both are not applied, then you should use reduce by key only, because it is simple to implement. Now it is done, and now I can say orders ag RDD dot take of 5 for each println. You will get only one order ID and the composite revenue or aggregated revenue for that order ID, instead of repeat of order IDs like we have seen earlier, because the data is already aggregated based on the key because of reduce by key. Now I have to filter on this again on the second attribute in the tuple. If it is greater than 1000, then only I want to see the results. So I can say orders ag RDD. I can apply filter condition here, underscore dot underscore 2, underscore represents the entire tuple, dot underscore 2 represent only the second element, greater than or equal to 1000, and for each println. You can see it is returning only those orders which have order revenue greater than 1000 and also cancelled, because we have first filtered out all the cancelled orders and then joined the dataset with order items, which fetch us around 3400 records, and then out of which we have aggregated the results, which fetches orders ag map orders ag rdd dot count. So out of 3415 we have only 1194 orders after the aggregation, and then we have applied filter condition again, and we have fetched only those cancelled orders which are greater than 1000, and you can get the count also. There are only 139 orders which are cancelled and greater than 1000. Out of 1400 cancelled orders, only 139 orders have the revenue greater than 1000. So if you want to apply this, implement this using SQL, it is pretty straightforward. You just have to import org.apache.hadoop, spark.sql.hive context, sql.hive.hive context, and then you have to get the SQL context equal to new hive context sc. It should be val, and then you can say SQL context dot SQL select order id comma sum of oi dot order item sub total from orders o join order items oi on o dot order id equal to oi dot order item order id, where o dot order status equal to cancelled, and yeah, so this will give all the cancelled orders dot for each println collect. I have to say group by o dot order id and hit enter. Yeah, because I didn't group earlier, it failed. Now you can see it is giving all the cancelled orders. You can actually say count. It returns around 3400 records probably. No, 1194, because we already aggregated, which is exactly same like we have seen earlier. Now if I want to get only orders which are greater than 1000, what I have to do is select star from. So I have to provide alias for this. I am saying order item subtotal or order item revenue. I'm just giving the alias for our aggregate function sum, and then I have to close this, give a alias to the query. So the q is for this one, it's an alias for this query, and then I have to apply where condition, where order item revenue is greater than or equal to 1000, and hit enter. Okay, The reason is I closed at inappropriate location. This double quote should be here, and hit enter. Now you can see that it is only returning 139, the same as our function 139. So you can write, if you are familiar with SQL, you can write a simple SQL to get the same results. So if I will recommend you to do so, unless they explicitly say that you have to implement everything in Spark. If you Spark Scala. So if you have to implement in Spark Scala for our logic, for our requirement of getting all the cancelled orders with amount greater than 1000, you can write this code. If you have to write it in SQL, you can write it like this by using a Hive context. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to ask any questions technically, please use Stack Overflow by tagging it properly. And if you want to discuss on Apache Spark or Hadoop certifications, please join my LinkedIn groups, ITversity, Apache Spark or ITversity Hadoop certifications. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. Thank you. Bye.